Hello, welcome. This is the Edexcel C4 January 2009 question number 3. Okay, and really all this is about is partial fractions and estimating certain equation. Okay, well, I say equation, summing in a value for the equation, but summing in a value for x. Sorry. Anyway, the first part of this equation has to split it up into partial fractions. And now, I always do it for you on the board, but nicely on this paper they have done what you do A over, what you do B over. They have split it up for you. We've just got to find the values of A, B and C. Now, so a couple of people talk about this in different ways, obviously. Now the way I think of it is timesing both sides by the denominator of the fraction you're splitting up, okay? So obviously, on the left-hand side, that leaves us with 27x squared plus 32x plus 16. Okay, and when we times a over 3x plus 2, we times that by 3x plus 2 all squared and 1 take x. Well, the 3x plus 2 squared, and that almost cancels out the one on the bottom, so we're just left with a brackets 3x plus 2. But the 1 take x doesn't cancel, so we add that in as well. So it's 1 take x. For b, well, clearly the 3x plus 2 all squared cancel, so we're just left with b times 1 take x. And then the c, well, obviously the 1 take x cancels, but the 3x squared, 3x take plus 2 all squared doesn't cancel with anything. Okay, and then it's just a case now of choosing suitable values to obtain values for a, b, and c. But we're told that find values for b and c and show that a is equal to 0. Okay. Well, obviously we need to find the individual values of b and c first, because presumably we won't be able to show that a is 0 until we found b and c, just through the wording of the question. Okay. So if we want to make one of the values equal to 0, what we do is we look at these factors here, okay? And you might want to draw it somewhere at the side and say, okay, if we want to find C, for example, we would make the factors associated with B and A equal to 0. And we can do that because we both have a factor of 1 take x. And say a factor is something we multiply it by. Okay, so if we want to make 1 take x equal to 0, then quite clearly we choose x to be 1. Okay, so we say let x equal 1. And if we do that, we get 27, we bracket times 1 squared, plus 32 times 1 plus 16 is equal to, well, obviously a is going to be times by 0, and so is b, but c isn't. Okay, because if x is 1, it's 3 times 1 plus 2, which is obviously 5 squared. Okay, so that's c times 25, or in other words, obviously 25c. Okay, and then it's just a case of simplifying this down. Well, quite clearly it's 27 plus 32 plus 16 is equal to 25c. Okay, so you just clearly add 27 plus 32 plus 16, which will get you obviously 75. So 75, get it right. 75 equals 25c. So obviously it's just a case of working out c, and if you do that, you get c to be equal to 3. Okay, so I just put c is equal to 3. Alright, so now we've got a value for c, we need to work out a value for b. And we work out the value for b, well, it's got a factor of 1 take x, but it doesn't, we need to make a and c equal to 0 to find b. And they both got a factor of 3x plus 2, so therefore we make 3x plus 2 equal to 0. Now, because I like to be certain about these things, and it's very easy just to simply make a mistake. As I said, a simple kind of thing that we did over here. If you want to make 3x plus 2 equal to 0, so quite clearly what you do is you rearrange it to 3x equals minus 2, so therefore x equals minus 2/3. So you'd say let x equal minus 2/3, so it'd be 27 times minus 2/3 all squared. So in other words, 27 times 4/9, but I'd wait until I wrote it all out before I write that. And plus 32 times negative 2/3, which is obviously negative 64 over 3, but again, wouldn't write that out just yet. Plus 16, well, a is going to have the factors equal to 0, so you might just want to ignore a altogether, but still I write a bracket 0, because a times 0. As I said, b is going to end up cancelling as well. So write b times 0. Oh, sorry. B times 0. So we want to find the value of b. So if we'll let x equal minus 2/3, well, it's 1 take minus 2/3. In other words, it's 1 plus 2/3, which is obviously 3 over 3 plus 2 over 3, which is 5/3. Okay, and c is going to be a factor of 0. Okay, so therefore it's just a case now of expanding this out. Now I said the first term was obviously 27 times 4/9, which is 12. Okay, and then it's take 64 over 3, which doesn't cancel to anything. So take 64 over 3 plus 16 is equal to 5b on 3. Now it's totally up to you how you rearrange this, but ideally I want a value of b, that's what it's saying. So it times all of the equation by 3, okay? Well, that quite clearly gets you 36, take 64, plus 16 times 3, which is obviously 48. Okay, that's equal to 5b. And then it's just a case of simplifying this down now, so 36, take 64, plus 48, it's obviously 20, so therefore 20 is equal to 5b, so therefore quite clearly b is equal to 4. Okay, so you put b equals 4. C is equal to 3. Now, we've worked out values for b and c, and it wants us, asks us to show that a is equal to 0. And now there's quite clearly no other methods that we can use to state that. So basically, what we need to do to get a on its own is we need to make the factors of b and c equal to 0. Well, the factors of a is b and the factors of b and c. So as I said, there's no way that we can just make a factor equal to 0 and be left with a on its own. So what we do instead is we choose another suitable value, okay? Now, obviously we can't choose 0 because that'd get rid of everything. Well, actually, no, we could choose 0. Yeah, why not choose 0? I was going to say we can't choose 0, actually we can. So if we assume let x be 0, okay, you might want to state it, as I said, I haven't really been doing, but in other words, that'd be 27. Yeah, 0 would be quite easy. Squared plus 32 times 0. So you still write this in, even though, can't bother to. As a times 2 times 1 plus b times 1 plus c times 2 squared, which is obviously 4. Okay, now we've got a value for b and c, okay, so we've put our values for b and c. Now I'm going to be lazy and just rub it out, okay, so b to be 4 and c to be 3, okay. So obviously it's now just a case of simplifying this down, expanding it out. Okay, so 16 is equal to 2a plus 4 plus 12. Okay, so therefore 16 is equal to 2a plus 16. But therefore a must be 2a is equal to 0, so therefore a is equal to 0, and that is as required. Now generally that won't occur. If you ever got that in one of these questions, then I would definitely recommend you going back and checking your working. But because it said state that a is 0, you would show this method, okay? Now as I said, the reason I didn't find out a before, well, we'd need to find out b and c, because as I said, there's no way of getting a on its own, and also it's asked us to show that a is 0, okay? So quite clearly we need to find b and c first, okay? So anyway, a is equal to 0. And what you might want to do is write that out. And now I've just been lazy and said a is 0, b is 4 and c is 3. But really, if you were doing this, then you would write underneath all your working, you would write this whole equation out again, and you put 27x squared plus 32x plus 16 over this is equal to 0 over 3x plus 2, or you just ignore that factor, but I would still write it in, plus 4 over 3x plus 2 all squared, plus 3 over 1 take x. Okay. Now, as I said, a little bit of a heads up, if you've ever got a b to be minus 4, as I said, you know, in something like this, then don't write plus minus 4, because that just looks like you're stupid, even though if you are, it's always better to try and hide that in the world, because, you know, people aren't such a big fan of people being stupid. Okay, so that's part A over and done with. It says 4 marks. Hence or otherwise, find the series expansion of fx in ascending power, so it's increasing, up to and including the term in x squared. Simplify each term. Now, quite clearly it's asking us to do binomial expansion, so that's why we've had to split it up into partial fractions and not just done it for fun. Otherwise, they might do, but generally when it's a big question, they won't really. Okay, now it says hence or otherwise, so for some reason you could go from that and just find the expansion of the big fraction, but it's a waste of time. You might as well just split these up into partial fractions. Okay, well we quite clearly know a is 0 over that, over 3x plus 2, so you can almost cross out a in your mind. Obviously I wouldn't cross it out in part A, even though it looks like what I've done, but you know, I have the powers, the shining light from the gods is bestowing itself on my brother's face. But anyway, back to this actual math stuff and this creepy YouTube guy. Okay, so anyway, what we need to do, let's see, right, f of x, and we need to put it in a form which looks like something you would use binomial expansion on. Well, quite clearly you wouldn't use binomial expansion on 4 over 3x plus 2 all squared. You're more likely to use binomial expansion. Obviously this isn't going to strictly work, we're going to have to do some faffing around this. 4 times 3x plus 2 all to the power of minus 2, because obviously we're bringing it up to the top, so we change the power to a minus. Okay, or do the negative for the power. And then we had 3 times 1 take x all to the power of negative 1. Now don't expand that, because obviously that wouldn't, you know, you wouldn't use binomial expansion on that. Now, what we need to do is convert these, because this is okay, this is in the form 1 plus x is 1 take x, but a is negative, okay, to the power n, so that's fine, it's tickety-boo, we can expand that. But this one, we're going to need to do some work on that, okay? So, before expanding either of these, what I would do is rewrite this now. So, f of x, let's change pen. We've got so many pens as well, you wouldn't think I'd know. Anyway, okay, so, what I need to do is obviously make this in the form, now, actually, before I do this, what we normally see is this 1 plus ax, but this is in the form ax plus 1, or it should be. So what I would do, actually, first off, is rewrite this, okay, is 2 plus 3x. Because it says exactly the same, but it makes it a hell of a lot easier when you're rearranging it to form in the form binomial expansion. Because what I did when I first attempted this paper, in genius I am, is made 3x 1, 1x or x. Well, quite clearly isn't the case, because 1 plus ax, so a can be anything, but obviously within reason. But we need the 1 there. Now, quite clearly 1 is a constant, it's just a number, so we need to make the number in front. Now, as I said, when you actually go to expand it, it doesn't matter which way around the 1 and the ax is, but when you're converting it to the form of 1 plus ax, you know, it's a bit kind of crucial. Now, as I said, you might do, while we're doing all this, why don't you just use the other binomial expansion that we learned way back in C2, that it doesn't matter, it doesn't have to be in the form 1 plus ax. Well, for that the power has to be an integer and positive. Why, this is an integer, but it's certainly not positive. Okay, so anyway, we sort of take the 4 out anyway, but we need to take out 2 as a common factor, so we divide it all by 2 inside, but we still take the 2 out with a power, so it's 2 to the power of negative 2, 1 plus 3x over 2, but there's all still to the power of negative 2. And 2 to the power of negative 2 is 1 over 2 squared, which is a quarter, so it's 1 over 4. Now you can quite clearly see that this 4 times a quarter is going to equal 1. So as I said, you might want to just, on your next line of work, and if you were going to write this out again, okay, you might want to write that as just 1 plus 3x over 2 all to the power negative 2. Or you might want to do the full expansion of this and then times it by 4. But as I said, it's a waste of time. Okay? As I said, the other term is perfectly acceptable already. We don't need to do any faffing around with that at all. Okay? So that's the terms, they're the terms now that we need to expand. Obviously I'm going to be rubbing all this out so it's all completely and utterly pointless. Okay? Right. So what we need to do now is, as I said, expand these individual terms. Alright, so using a standard expansion of the 1 plus ax to the power n, we need to expand the individual terms and then add the sum of the expansion of this up to x squared and the sum of the expansion of this up to x squared together to give the whole expansion for f of x. Okay, so the first one I'm going to do is probably the easy one. Okay, it's this second one here. So if we're going to expand 3 brackets 1 take x all to the power of negative 1, so I'll bracket it off because I'm just can like that. Okay, well obviously we're going to need to take 3 out. And we're doing it up to the term in x squared, remember. Okay, so if we were to do that, it would be 1 plus... Now, as I said, what I would normally do actually is write what a and n are. Okay, well a is obviously negative x and b is equal to negative 1. Okay, so the first term is 1 plus an, so it's negative x times negative 1. Which is quite clearly plus x, but you leave it there. Okay, and then it's minus 1, take 2, over, minus 1 times minus 2, over 2 times 1, which is obviously just 1, times a squared, so it's negative x squared, which is obviously just x squared, but still put negative there. Okay, and then it's just a case of expanding this out now, so 3 times 1 is 3, 3 times what this will come to is x, is obviously just 3x. Okay, and obviously that cancels, so it's 3 times x squared, which is obviously just plus 3x squared. Okay, so that's your expansion for your second term. We also need to expand the other term. Okay, now probably should run that ball rubber. I need to know this up. So welcome to the second part of not second part, just kind of sorted it out on the board really for you. Okay, so as I said, that is the answer to the second half of the expansion. Okay. So this first bit here, we're doing exactly the same method, okay? So we're going to expand 1 plus 3x over 2 all to the power of negative 2, okay? So exact same principle, we don't need to times it by anything. Okay, so it's 1 plus an, a being 3x over 2, and n being minus 2. Okay, I'm doing it up to x squared again, okay? So it's minus 2 times minus 3 over 2 times 1 times a squared, which is 3x over 2 all squared. Okay? Sorry to apologise. Okay, and then it's just a case of expanding this and then simplifying it. Okay, well obviously it simplifies to 1, take 3x, well the 2 times negative 2 times negative 3, or like positive 6, sorry, but they cancel with a 2, okay, so that becomes 3 times 3x over 2 all squared, which obviously becomes 9x squared over 4, and you times that by the 3, okay, which is, sorry, I'm just making sure I've not gone absolutely insane. So it's by the 3, which gives you 27x squared on 4, didn't know that obviously. Plus 27x squared over 4. Okay, so that's your answer for the first part. So you add this 3 plus 3x plus 3x squared to the 1, take 3x plus 27x squared on 4, okay, to get the total expansion for f of x. Okay, well you add the 1 and 3 together quite clearly. So it's 4 and the x cancels plus 0x. Okay, but you still write 0x even though there's nothing there, just to show you've considered x as well. And then you add 27 over 4 to 3, which is 39x squared over 4. Okay, and that is your answer for the expansion of f of x up to and including the term in x squared. Okay, now you might have done it all into x cubed just to make sure that there was no extra x squared that you were missing, okay, but that is the correct answer there, okay. So hopefully that makes some kind of sense, and we'll hopefully see you in the next question, which obviously, if you can count, will be question 4, which hopefully you can.